This is the last problem from our review. It says a recent data show that 73% of Kenyatta College students smoke. Write the notation for this probability distribution. Write the probability distribution notation. I guess that's repeating the same thing. So what we want to do is take a look at each of these things. The probability distribution notation for this would be an X and then that tilde, remember. It's calling for a binomial distribution, so it's a B. And then the N is actually going to change for each of these parts, because in the first one we have 20 Kenyatta College students, in the second one we have 30, and the third one we have 40. So we'll call that N, but our probability looks like it's going to be the same here. It's 0.73, 73%. So this would be, at this point, our general probability distribution. But like I said, when we come to this first problem, we're going to be looking at writing it a certain way. So our probability distribution here was going to be with 20 students. Now, if we select 20 Kenyatta College students, what's the probability that exactly half of them would smoke? So for this particular problem, we're looking at the probability that exactly, and you can just put 20 here, or half of 20 is 10, sorry. You could put 10 here, but it would be a good idea whenever you're dealing with probability distributions that you're saying X is exactly or equal to 10. And so in that case, we have a binomial distribution going on with N is equal to 20 and P is equal to 0.73. So for this, it's a calculator command, and I'm hoping that we're all familiar with this. It's binom PDF. The P stands for probability distribution, and we're finding the exact value at 10. So the probability distribution, the binom PDF in the calculator asks for N and P, and whatever X value you choose. In this case, we're looking at what happens exactly at 10. And so let's punch that in our calculators. The binom PDF can be found if you hit second function and vars. That's the DISTR. That's distribution. And there's a handful that we're going to be using in the future, but for now we'll look for binom PDF. Notice one right below is CDF. That's going to be important for our next part, but for now it's going to be PDF for exactly 1. And our values are 20, 0.73, and 10. So we hit enter, we get our percentage 0.0163 or 1.63%. Pretty small. So that's our first problem. Our next problem gives us, again, a different distribution. It's still a binomial distribution, but now our N is 30 because we're selecting 30 Kenyatta College students. So here we're looking at what the probability is that we have less than 10 of them smoke. So in terms of notation, let's use P of your X is strictly less than 10. So the strictly less than is important here also, to say that it's 10 but it's not including 10. So for this, what we can do is we can add up a whole bunch of binomial distributions, binomial probabilities from 0 through 10, or actually from 0 through 9. But to add up all those probabilities, all we have to do is find the cumulative distribution. Remember the cumulative relative frequency? It's adding up all those numbers that's less than that, so less than 10. For that, there's another command here. Second and vars, our distribution. So there's a binom PDF, and then right after that is binom CDF, and C stands for cumulative. So we'll select that. Our N now is 30. Remember, it changed. Our probability hasn't changed. That's still 0.7. And then remember that we're going up to 9. We're not including 10. We only go up to 9. So that's very important for this particular problem. So a result, now if you put 1.13 and stop there, that would be incorrect, because your probabilities have to be between 0 and 1. Clearly 1.13 is not between 0 and 1. What is included in your answer here is e to the negative 6. What that says is you're going to take your decimal point and move it 6 places to the right. And what that gives you is 5 zeros after your decimal point, and then the 113. So you can write it this way, either of these ways. Or if you think this is something that's really small enough, now I have to warn you that if you put 0, that would be incorrect also. It's really close to 0, but saying a probability is equal to 0 is saying that this is an impossible event. This is not an impossible event. So to deal with that, sometimes the book uses, or some books uses 0.000, or they say 0 with a plus sign next to it to say it's really close to 0, but it's not exactly 0. So I can take any of these answers over here. Oh, by the way, the calculator command was important also. Binom CDF. And then our values were 30, 0.73, and 9. Okay, so any of these responses over here I'll get as marked as correct. Alright, now the last one. It's asking us if we have 40 students this time. What's the probability that we select at least 30 of them? Now, at least 30, what does that mean? That means, oops, excuse me. At least 30 means our x value is bigger than or equal to 30. Now, that's not the best way to put that symbol, but for now I'll just keep it as that. So bigger than or equal to 30. And remember, our binomial distribution here has changed a little bit. Now what we want to do here in this particular problem is we want to count up to our choices for our binomial distribution is either a binom PDF or a binom CDF. So these are our two possibilities. Now what we can do is we can go find the binom PDF for 30, 31, 32, 33, all the way up to 40, which is doable, but that seems to be more work than what's needed. Or we can take advantage of the fact that if this is a probability distribution, all those probabilities need to add up to 1. And so if we take the total of probabilities, that's all equal to 1, and then the cumulative probability distribution counts from the bottom 0 all the way up to a certain point, then maybe we can use the binom CDF and then subtract it from 1. So that's going to be our key. First we're going to find the binom CDF of this particular scenario. So it's n is 40 and p is 73, but we're only going to add up the distribution, the random variables or the probabilities, from 0 all the way up to 29. So what's going to be left is 30, 31, 32 all the way up to 40. And then once we figure out what this binomial distribution is, we're going to subtract it from 1. Now we could do this all in one step in the calculator, but I think it's important to show what actually happens. So let's take a look at a binom CDF, and 40.73 and 29, and this gives us a 0.53154. Since this is an intermediate calculation, I usually prefer to put as many decimal places as possible and then actually do the subtraction from there. So to figure this out, I'm going to say 1 minus that thing that I just got. So that's 0.531. By the way, if you want to recover a previous answer in the middle of an expression, like in this case I want to put this whole thing here instead of retyping it over, I can press 1 minus, and then the ANS stands for answer. That's your previous answer, and then this is going to give us a result. So 0.46845, and this is the final result, so I can just round off here. So what I was saying earlier is that you could have done this all in one step in your calculator. You could have just typed in 1 and then a minus and then search for that binom CDF. So the binom CDF, and then you put in your n, you put in your p, and then you put in your x value that you want, and then you're going to get the same result. Okay, so that takes care of the binomial distribution sets of problems, and that should be it for the review. Good luck on the test.